Number 25 wants us to do discontinuity, holes, intercepts, asymptotes, limit and behavior, and sketches. So basically, you remember when we did this, all the stuff that you learned about how to graph functions and stuff comes into play. So the first thing you always do is factor. So the top one, we're going to factor out an x, and we get x squared minus x minus 12. And that would factor to x times x minus 4, x plus 3. And then the bottom, let's see, would factor to negative 2. Let's take a negative 2 out. And I get x squared plus 2, no, not plus. When I took the negative 2 out, that changed to minus. So x squared minus 2x minus 3. And so then we'll have a negative 2, and then it's x minus 3, x plus 1. All right, and then we look at this function. So this is what's going to help us graph. And we have nothing we can cross out. We have an x plus 3 over x minus, can't do that. So we don't have any holes. So the first thing I can say is there are no holes. But we have two places, and I'll use the yellow right here and here, where we have vertical asymptotes and some discontinuity. So we would say that we have a vertical asymptotes, and at x equals 3 and x equals negative 1. And we'll graph those in a minute. And then, so that means we have, I'm going to move down here, vertical, we have infinite, couldn't think of the word for a minute, infinite discontinuity at x equals 3 and x equals negative 1. So let's get this negative 1 asymptote in, and 3. Okay, that means since we have two asymptote verticals, we're going to have a 3-piece function. Now we want to go for the horizontal, but if you notice, the degree on the top is bigger than the degree on the bottom. So that means I have slant asymptotes, so I do long division to figure out what that will be. So I'm going to do that down here. Negative 2x squared plus 4x plus 6 going into x cubed minus x squared minus 12x plus 0. So this would be negative 2x, which would give me, no, you know what? That would give me 4. So what does it have to be to have just a 1? It would be negative 1/2 x, right? That would give me x cubed. And then that would be 4x times negative 1/2 x would be minus 2x squared. And then 6 now. 6 times negative 1/2 would be negative 3x. Okay, phew. I think I got through that. Tricky. So subtracting this, negative x minus negative 2x gives me a positive x. Uh-oh, yeah, did I do it right? Hang on. I might have had something wrong in the original problem, because I didn't get the same thing. Okay, let's keep going. Negative 1/2 x, and then, okay, negative x plus minus negative 2x is plus 2x squared, so that would give me a x squared. And then negative 12 plus 3 would be minus 9. Okay, so 9x. So the next one would be, how do I go from this? This would be then minus 1/2. So I don't have to go any further. This is going to be my slant asymptote. So y equals negative 1/2 x minus 1/2. So start at negative 1/2 and go down 1 and over 2. So I'm looking at this, down 1 over 2, up 1 over 2, right here, and 1 over 2. So do a couple more, up 1 over 2, 1 over 2. Okay, so there's my line. Okay, so I know I'm going to have a piece in here, a piece on this side, and a piece on this side. So let's just figure out, well, let's continue. What else does it ask for? Points of discontinuity. So I've got, there are no holes, and there's, I have the infinite discontinuity. And so now I also can say that I have the horizontal asymptotes are not, so no horizontal asymptotes. And you have the vertical slant. You don't have to put this, but it helps you graph it. Y equals negative 1/2 x minus 1/2. And let's see. Okay, we need the x-intercepts. So the x-intercepts are the same thing as the zeros. And to do that, you use the numerator. So we're looking over here at the numerator, and where, if you set that equal to 0, you would have zeros at 0, 4, and negative 3. So x-intercepts at 0, 0, 4, 0, and negative 3, 0. So we can put those in. So I've got one there. Let me use, let's use red for my actual graph. There I go. I got a point there. I have 4, 0. That tells me this one is here. The only way it could be. Okay. And, all right. And negative 3. So negative 1, 2, 3. So that also tells me that graph is there. So I have my two end pieces, and then I just need my middle piece. Okay, so let's see. It asks for vertical asymptotes. Okay, end behavior. And, all right, so my only x-intercept, or y-intercept, will be 0, 0. So y-intercept is 0, 0. So the thing I have to do is figure out what's going on between negative 1 and 3. So let's go and do an XY chart and where all we care about is the signs. So watch me do this XY chart with the signs. So I'm going to have, for the first one, I'm going to let's pick 2. What's going on at 2? So then if I put 2 up here into my function, actually here where it's easier, it would be x, which would be 2. So that would be positive. And then 2 minus 4 is negative. And then 2 plus 3 is positive. So that's the top, multiplying those. And then I'm just caring about the signs. I have a negative for the negative 2. I have a negative for 2 minus 3. And I have a positive for 2 plus 1. So altogether, that would give me a negative. Because on the top I would get, I don't know why I'm saying negative 1, just a negative. On the top I would get a negative and over a positive on the bottom. So that's a negative. So that means that it's down here and it has to hug this guy. And now we have to do negative 1/2. I mean, you could do anything between negative 1 and 0, but I'm doing 1/2. So we're just caring again about signs. So the top would be a negative 1/2, so that'd be negative. And then negative 1/2 minus 4, negative. And negative 1/2 plus 3 would be a positive. Over, this saves you time, you don't have to do the numbers. Negative for the negative 2. And then negative for the x minus 3. And then positive. So you would get a positive altogether. So that means this one hugs this. So there's my sketch. Now all I have to do is end behavior. So let me add the end behavior. So you'd say the limit as x goes to infinity, meaning your x term going this way, where's y going? Y's going to negative infinity. And the limit as x goes to negative infinity of the function, where's it going? Okay, it's going up here, so that would be positive infinity. All right, so there was number 25.